everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion we have taken today is evaluation of double integrals for the bounded regions. In this video lecture, what we are going to discuss about is definition of double integrals in Cartesian as well as polar coordinates, and problems based on double integrals for the bounded regions in Cartesian coordinates, and also problems based on double integrals for the bounded regions in polar coordinates. These are the three topics we are going to discuss in this video lecture. A double integral in Cartesian coordinates. What is the formula? That is, the double integral, here the capital R, which is denoted here, that is, it represents region. Then the function f of x comma y, that is, the function, it is described in terms of variables x and y. Two variables are selected because it is double integral. That is, the definite integral which is extended to two variables, then it is double integral. The Cartesian coordinate, that is in x-axis and y-axis, that is, it is defined in xy plane. The total, the region we are going to find. So the total region in two dimensions, that is dx and dy. So the double integral formula, it's nothing but f of xy into dx dy. Now the double integral in polar coordinates. Here the interior integration is from R1 to R2, that is a radius. The outermost integration is from theta 1 to theta 2. Here the function which is defined in terms of r and theta, and we will do the integration with respect to r and theta. This Cartesian dx dy, we should modify according to the limits. If the interior integration it is defined for y, then we will do the integration with respect to y first. Then we will do dy by dx. Similarly, here also, the interior one it is defined for theta, then we will do d theta dr. So according to the limits, we have to modify with respect to r first or r theta. Here also with respect to x first or y first, we have to take decision depending on the limits priority. So now this is nothing but the polar form of the double integration. Problem: evaluate double integral xy by square root of 1 minus y square dx dy. Over the first quadrant of the circle, x square plus y square equal to 1. The solution is, first we are reading the question. Evaluate this integral. Looking at the integral, dx dy, two variables, they are dominating, and the integral also two integral symbols are there. So which gives an indication that the clear picture about the question, the given problem comes under double integration in Cartesian form. So that point is very clear to us. So according to that, it is two-dimensional. So we are writing, we have taken x-axis and we have taken y-axis. This is the origin. We are representing as O. The coordinate is 0, 0. X-axis we have written, y-axis we have written, because our given problem is two-dimension in Cartesian form. That is xy plane. Fine. The next one, circle, it is there. We know it, circle, we have to draw. But in this particular problem, we didn't draw the complete circle. But we know it, circle, it is the full complete circle we will use to draw. But this particular problem, only 1/4 of the circle only we have taken. The reason is here the another word is given, first quadrant. That is, the 4 quadrants are there. This quadrant only is called first quadrant, only the circle which lies, which is given our problem condition. So that is the reason now only the first quadrant only the circle curve which is drawn here. The next one is, another one doubt is coming to our mind. Now this first quadrant we have drawn the circle. Why we can draw even a big circle? Otherwise we can draw big. It goes on. So here the one doubt it is coming. This curve, the first quadrant, the part of the curve of the circle at the x-axis at which point it is touching, at the end of the curve at on y-axis at which point it is touching. That those points we want it now. So now, so this is the curve. It's nothing but this is the equation of the circle, from which we know it our origin 0, 0. So we are going to substitute when x equal to 0. We got it, the value is, y value is 1. And we are substituting this y equal to 0. We got it x equal to 1. So now P, this point, we are naming as capital P, and it touches at x-axis at the point 1. That's what this is mentioned here. 1, 0. X is 1, y is 0. This point name we are giving Q. And here x is 0, y is 1. So Q of 0, 1. Fine. So this particular problem, we have drawn 1/4 of the circle according to our first quadrant, and they are touching at x-axis, at y-axis, at what point? We got it. Now, this complete integration we have to find. That means the area we have to find, the region, the bounded region. This is the bounded region. We can see the vertical lines. This complete, I'm putting here. The lines are there in pink color. Those lines, complete area we have to find. How to find the area? We have taken vertically. We are going to calculate. One more doubt will come. Why we have to calculate the lines we have taken? Vertical strips taking we are going to do. Why can't we can take horizontal strips? Like that also we can do it. Nothing wrong in it. But for the discussion, Now we have taken vertical strip. This vertical strip, we have given the name A and B. This complete region, the area we have to find. That is only our question. This vertical strip, the y-axis, from where it starts, where it ends, that point we must know it. The vertical strip, the starting, this is the complete region we want it. In this, y is playing the role 0. From 0 to where it touches the curve. So from here we are going to extract what is y. So y square equal to 1 minus x square, y equal to square root of 1 minus x square. So y from 0 to this, y equal to square root of 1 minus x square, that is the limit. Then what about x? This vertical strip, left point we have to see. The left point is 0, 0. In this 0, 0, what is x? 0. In this vertical strip, the right point, what is there? P of 1, 0. Here, what x is playing the role? 1. So, very clear picture about regarding x. The limits are from 0 to 1. So, reading the question, we have drawn the diagram and the limits also we found. We will proceed further solution. So this is the diagram we have drawn for the given problem. So the region of integration, that is O2, P and Q. This is the bounded region. And we are going to do integration. Any variable, first we can do dy, otherwise we can do dx. Anything, both are correct. Now this is the vertical strip AB, which is parallel to our y-axis. That's what it is written here. And the vertical strips starts from x-axis and it terminates touching the curve, that is our circle. Limits, y limit, it is written y equal to 0 because our region, this is O, that is 0, 0. Here y is 0, y is 0, this one. From where it touches that curve, from here we will get it. What is y? The y is nothing but square root of 1 minus x square. X, the vertical strip, left side, x is 0. It is written here. For the right side, the point x equal to 1. So the limits we got in for this to calculate the bounded region. If we are taking vertical strip, this is the procedure to be followed for every problem. Now, the integration. The interior one we decided to take with respect to y. We are going to do the integration. That's what the interior integration, which is defined for y, the integration as a function of x. The outermost we have taken with respect to x, so 0 to 1. Now, so the interior integration, this one, with respect to y, we are going to do. Keeping as it is, we can do it, nothing wrong in it. But we don't want to make complicate this problem. That is the reason. Anyway, we are going to do with respect to y. X can be treated, this X can be treated as constant. That is the reason before we kept it. This is the way also we can do it to avoid the confusions and unwanted errors and mistakes. So now this part, it is kept in the square bracket, separate. First we are going to focus this interior integration first. So it is written separately. The idea is the interior integration we will do first. We will do integration first. After integrating, this result will be substituted in this particular place. So this is the integration. Now, here 1 divided by square root of 1 minus y square is there. According to exponential law, we know it, a power 1 by a power m can be written as a power minus m. So which is equal to here square root of, so 1 minute. So I am writing once again same. That is 1 by 1 minus y square 1 by 2. So we can write 1 minus y square minus 1 by 2 according to this exponential law. That's what it is written here. Now, the next step, this y is written, every term is written as it is, but suddenly we introduced here minus 2 is there and here 1 minus 1 by 2 it is there. Why suddenly we have to take? But mathematically it is balancing. That is, multiply and divide by minus 2 we did. For this it is kept here, for this we kept here. Mathematically it is balancing, nothing wrong in it. But the doubt is why we have to do it suddenly. The reason, the answer is, we have to make our integration in a very easy manner. We want to do it. So, we are going to take help from an easy integral formula. That is, f of x, it has some power n. This particular f of x, we will do the first derivative. That is, one time we are going to the differentiation. If in this format the integration, if it is there, now this part we are taking as f of x according to this formula, and this minus power minus 1 by 2 it is taken as this n. So the next it should be f dash of x. So if we are taking this is as f of x, then what about f dash of x? It should be minus 2y. We want it in this place. But we have, unfortunately, instead of minus 2y, we have only y. We needed this minus 2. So we multiplied minus 2. If we only multiply, mathematically it is wrong. We have to balance it. That's why multiply and divide by minus 2 we did. Because keeping in our mind, we decided to apply this formula which will make our integration very, very easy and time-saving procedure also. So now, this is f of x playing the role. This is n is playing the role. This is f dash of x is playing the role. So this is the result. We will apply it. So we applied f of x is nothing but 1 minus y square. The power is n plus 1. We have our n is minus 1 by 2 plus 1. It's nothing but 1 by 2. It is kept divided by n plus 1. Here also 1 by 2, we integrated, and the limits lower is 0. The upper one is square root of 1 minus x square. This minus 1 by 2, it is kept as it is. Now, we are substituting the limits. This 2, here 1 by 2 is there. The next step, here 1 by 2, this one. This 1 by 2 upcoming, it is getting cancelled. The remaining is only minus. Here this 1 is written as it is. This minus is written as it is. Y square. In this place, we are going to substitute here square root of 1 minus x square, the whole square. This cancelled. So 1 minus x square. This 1 by 2 is written as it is. Upper limit. The work regarding upper limit we completed. This is formula minus for limit. Upper limit minus lower limit. The lower one is, in the place of y we are substituting. So 1 minus 0 is 1. So this minus is written here, and here 1 minus, this is 1. This minus is written as it is. X square 1 by 2 is x. This minus 1. Now 1 minus 1 plus x minus 1. This cancelled. We got it x minus 1. This minus we didn't touch at all. We are bringing as it is. Now, this is the integration we are focusing. We have taken this interior integration separately, and this is the result we got it. For this particular thing, we got the result minus of x minus 1 is the result. We got it. So that we substituted in this place. The leftover is this one as it is written. This x we brought it as it is. Dx we brought it as it is. Now the next step, this minus we brought it out. X into x we wrote it. Remaining as it is we have written. The next step we are writing minus x into x, it has become x square. Then x we are taking inside. X into minus 1, it has become minus x. The integral of x power n dx, it's nothing but x power n plus 1 by n plus 1. Very simple integral formula that we are going to apply in this particular places. When we are applying this, our n is playing a role 2 according to this formula. So 2 plus 1 by 2 plus 1. This minus is as it is. Here for integral of x square dx is x cube by 3. This minus is as it is. Now this integral of x power 1 dx, it's nothing but 1 plus 1 by 1 plus 1, x square by 2, 0 to 1. This minus is as it is. Upper limit is 1. We are going to substitute in the place of x 1. So when we are substituting here 1 by 3, this is minus, here also minus, and 1 by 2. We completed the work regarding upper limit. So we didn't write about anything about this lower limit, because the reason is, if we write here, it will become 0 only, because x is taking the value 0. Here also 0. That's the reason here. Anyway, it is becoming 0. It is not mentioned here. So simplifying now. So we are taking the LCM. 2 minus 3 by 6. It's nothing but 1 by 6. So we completed one problem regarding Cartesian form bounded region. So the next problem, evaluate double integral x square minus y square dx dy over the triangle. Before one we discussed about a circle, now triangle with the vertices 0, 1, 1, 1 and 1, 2. The solution is, reading the question, we are getting an idea about the given problem comes under double integral, looking at the two integral symbols, and dx dy. It gives an indication that the given problem is double integral regarding xy plane, that is our Cartesian plane. That is the reason here this is the origin 0, 0. It is named as O. Two dimension we selected because our question it is in xy plane, x axis, y axis. Now the vertices 0, 1 to be marked. We marked it 0. That is x axis 0, y is 1. The point we are naming as P. And the next is x is 1, y is 1. The point we kept it Q. The next is x is 1, y is 2. The same actually distance should be there. Distance 2. Yeah, fine. So joining these 3 points, 3 vertices, vertex, vertices. So the 3 joining, we got it. A triangle, we got it. This triangle, the area, the bounded region area we have to find. That is only our given problem condition. We have to solve it. So reading the problem, we have drawn the diagram. This is the area we wanted. This area to do calculation, we are going to do vertical strip we are going to take. The vertical strip we are naming as A and B. If we are taking the vertical strip, limits to be found. Why limit? The condition is this area bounded region, the lower limit is what we have to see. And upper limit is what? For the limit of y. So now we can say it here. So the lower one is 1 it starts. For y limit I'm telling. And here it is there. This is the equation of straight line. This equation of the straight line, 2 points are there. 0, 1 is one coordinate and 1, 2 is another point. We know the equation of line passing through 2 points. That formula to be used and we will be getting this equation of line. So regarding this vertical strip, limits of y, we got an idea. And what about x limits? This vertical strip, left side we have to see. The left side is 0, 1. So here, what about 0, 1 and here 1, 1. That equation of line is also y equal to 1. So now we can see it in detail. We can see about this problem. The region of integration is triangle PQR. It is there. So now equation of line PQ we are taking, that is y equal to 1. Y minus, that is 0, 1 we have taken, 1, 1 we have taken. This is x1, y1. This is x2, y2. So y minus y1. Here y2 minus x2. y2 minus x2 divided by, y2 minus y1. y2 minus y1 by x2 minus x1 into x minus x1. It's what we studied in lower classes, that is passing through 2 points. That equation of line formula we used it, that is y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. This is the formula we used it. We solved it. Y minus 1 equal to 0. We got it y equal to 1. So the next one is, so this is actually a diagram. Now equation of the line PR. Here also one point is there. Here another point is there. So the equation of line PR passing through these 2 points. So the same formula, 0, 1, x1, y1 and 1, 2, x2, y2. We substituted y minus y1. Here y2 minus y1, these two. Next x2 minus x1 into x minus x1. We solved it. So y minus 1. This solving we got it x. It's nothing but y equal to x plus 1. So this equation of line we got it y equal to x plus 1. Now the integration can be done. The first thing, the interior integration with respect to x we have to do, or with respect to y we have to do. Anything it is possible in this problem. Now in this particular problem, for the explanation, we have taken vertical strip we have taken. So the vertical strip which is parallel to our y-axis. Our vertical strip name is AB. Now this vertical strip starts from the line. This line it starts. This line is nothing but y equal to 1. And where it ends touching this line. That line it's nothing but y equal to x plus 1. So the y limits are ready. From where it starts, where it ends. The next one is, so now the limits, y limit is very clear from 1 to x plus 1. Next, limits of x. The vertical strip it is there. The left side of the point we have to see. In this, what is x? X is nothing but 0. The right point, what is x? X is equal to 1. So now, our given problem, the interior one, we are going to do integration with respect to y. That means the interior integration which is defined for y, and the integration is a function of x. The interior integration first we will do it, and we will concentrate the outermost one afterwards. So the interior integration, it is circled here. So now this interior integration we have written here separately. We are going to do with respect to y. That is the reason x square is treated as constant. We can use the word here partial integration also we can use it. Nothing wrong in it. It's not a simple integration. We can use the word here partial integration. It is a correct word. We can use it here because we are doing integral x square dy. We are treating this x square as constant. For dy purpose, we are writing y. It's nothing but partial integration. And this minus is written as it is. This y square is there. So integral y square dy, our integral formula, that is x power n dx formula is x power n plus 1 by n plus 1. This formula we are using y power 2 plus 1 by 2 plus 1. It's nothing but y cube by 3, and the upper limit is x plus 1, the lower limit is 1. Here also 1 should come. So we have taken the interior integration separately. There is nothing but there is an interior integration which is defined for y. So that is the reason we did with respect to y the integration, and it is a function of x. So this integration, we can call it as even partial integration. That is, we are going to do integration with respect to y, and we are going to treat the another variable x as constant. So instead of, even if you want, we can use it, partial integration is the correct word of doing this integration. So x square, it is written as it is, treating as constant. Dy integration is y. Minus is written as it is. Y square, the integral, that is following the formula. Integral x power n dx, it's nothing but x power n plus 1 by n plus 1. Here our n is playing the role 2. So 2 plus 1 is 3, 3 by 3. So the limits, the upper one is x plus 1, the lower one is 1. So in the place of y, we are going to substitute the upper limit x plus 1. So x square as it is, y is replaced by our upper limit x plus 1 minus the y is replaced by x plus 1, the cube is written as it is, the 3 is written as it is. So the upper limit, the work is completed. This is formula minus. The lower limit is 1. So in the place of y, we are substituting. So x square into y, that is y, it is taking the value 1. So x square, this minus is as it is. Y cube by 3, that is 1 by 3. We completed the lower limit, the value substituting in the place of y, it has taken 1. So the simplifications, x square into x, x cube, x square into 1, x square, this minus is written, this x plus 1 the whole cube by 3, minus we are taking inside, minus into minus, plus. So this interior integration, the job is over. So it is completely replaced by this integral, this x square getting cancelled. The remaining 3 terms are there, they are written here. The outermost integral, just we copied it. Now the outermost integral we have to do with respect to x. Interior one already we concentrated with respect to y, the integration. Now the outermost integration is x cube integral is x power 4 by 4. This minus sign as it is. This 3 also here it is written into x plus 1 the whole cube dx we want it. That is x plus 1 the whole power 4 by 4. Already 3 is the 3 into 4, 12. That's what here it is written. 12. The numerator is dominated by x plus 1 the whole power 4. Integral of dx, it's nothing but x. Here x, this 3 is written as it is. So we completed the integration with respect to x. Now we have to substitute the limits. The upper one is 1. So in the place of x we substituted, it is become 1 by 4 minus as it is. Here 1 we are substituting. So 1 plus 1, the whole power 4, it's nothing but 2 power 4, 16. This 12 is written as it is, plus as it is. X is taking the value 1, it has become 1 by 3. Upper limit is completed. Formula minus. The lower limit is 0. So x place we are substituting 0. So everything it has become. It is not everything. The first term and the third term it has become 0. The reason is in the middle term if you are noticing here 0 applying 0 plus 1 it has become. So 1 power 4 is 1. So minus 1 by 12. This is limit formula sign. This is our problem sign. So the difference we must know it. So the next one is here. Here 1 by 4. Here 1 by 3. Put together it has become 7 by 12. This is minus 16 by 12. Here minus into minus it has become plus. So minus 16 by 12 plus 1 by 12 it has become minus 15 by 12. Again we are doing simplifications. We are taking LCM. It has become minus 8 by 12. 8 by 12 we have given the lowest form of fraction, that is taking 4 as common. The result, the final result, it has become minus 2 by 3. So the one more problem, we concentrated 2 problems in Cartesian form. Now this problem, it is in polar coordinate in double integration. So the simple 2 integrals are there. So double integration and theta and r are dominating, radius and angle. The function is defined in terms of r and theta. That is the reason this here polar coordinates our given problem is. Now over the interior of the circle, that is r equal to 2a cos theta. Looking at the question, it is 2-dimension. So the solution we will concentrate. Given, just we have written the question once again. As it is 2-dimension, we have taken x-axis and y-axis. This origin, it is named as O. The coordinates are 0, 0. The circle, that is, here it is given circle. Over the interior of the circle. Now, the question condition is given r equal to 2a cos theta. If we take at angle theta equal to 0, if we take here 0, it is becoming 2a at theta equal to 0. Because cos 0, we know it is 1. So the radius is 2a. So here this is nothing but the angle here is 0. So the radius, it moves up to 2a. Next, here we will put it pi by 2. Which values are we are very familiar, the trigonometric values. Cos 90. So we are cos 90, we know it is 0. So when it is r equal to 0, when theta equal to pi by 2. Here we are substituting in the place of theta. It gives r equal to 0. That means from 0 here coming some to extend some radius, it is going when it touches the pi by 2, it touching at the radius is becoming 0. The next one is, so we have written here r equal to 2a cos theta. This is the interior region we have to find. Theta equal to 0. When theta equal to 90 degree, here it is there, it touches here. When theta equal to, this is pi by 2, this is automatically minus pi by 2. If you put it here, this point it's nothing but we know it initial line. Again it is coming back. If you put here 2 pi, cos 2 pi we know it 1. So the circle again coming back here. See a complete circle. This is the interior region we have to find. As it is a polar coordinate, we must know radius and theta here. Then only it is possible to calculate. So here this strip we have taken from the origin 0, 0 and we are naming as O. The starting is O. The ending the circle touches the circle at the point A. So this is the picture. So the region of the integration. So we can see the dotted lines. This complete region, the area of bounded region we have to find. It is in polar form. That is r equal to 2a cos theta, satisfying the circle is drawn. Limits we have to find. We want it radius from where to where. Here the radius is here the initial point. It starts from 0 to, it touches the circle, the curve 2a cos theta. So the radius job is over. The next one is, the theta is from pi by 2 to a complete, it is there, it touches the first and the fourth coordinate. So minus pi 92 and here the touching, here it starts and so minus 92, 90. So the figure once again it is kept. So this is the given problem. The interior integration is defined for R. So we have to do the interior integration with respect to R only. We are going to concentrate the interior integration in a separate way. That's what it is kept it in the square bracket. To avoid the confusion, we are doing like this. First, we will concentrate separately the interior integration. Getting the result in the particular place, we will substitute. So, r power 4 dr, as usual, our simple formula, integral formula, x power n plus 1 by n plus 1. Our n is 4. So, r power 5 by 5, 0 to 2a cos theta. This 1 by 5 it is written. R is replaced by 2a cos theta, the whole power 5. This is formula minus. Then R place, the lower limit is taking the value 0. So we got it. Here 2 power 5, it's nothing but 32 a power 5 by 5. Cos theta, the whole power 5 is cos 5 theta. So the interior integration we completed, we substituted in the particular place. these are the outermost integral regarding terms. So this 32a power 5 by 5, just we put it front of the integral. So minus pi by 2 power pi by 2. Now cos power 5 theta cos cube theta, it's put together cos power 8 theta d theta. Now this is written as it is. So now minus a to a, we can write it 2 into 0 to pi by 2 cos power 8 theta d theta. We used the formula. Next, 32a power 5 by 5, this 2 put together, it has become here 64a power 5 by 5, 0 to pi by 2 cos power 8 theta d theta. Now our cos power is 8, we have to do the integration. If it is only a single cos theta, it is very easy. We will tell sin theta. Quickly we can solve the problem. But our cos is having the power 8. So to do the integration, our 8 is an even number. So when it is even, we can use this formula. So according to that, so this formula is a reduction formula. We used it here. So 64 a power 5 by 5. Here we substituted 8. Here also 8. So we got it 7 by 8. Again the next here 8 minus 3, 5. 8 minus 2, 6. If we continue the problem, n minus 5, then here 8 minus 5, it's nothing but 3. Here this is n minus 2, the next n minus 4. So 8 minus 4 equal to 4. If we continue, the last term is 1 by 2 pi by 2. Very simple thing regarding cos. If it is even, this is the formula to be used. Suppose if it is odd, any power comes, this formula to be used. So now the simplifications, we have to do it. Getting the cancellations, we got the final result 7 pi a power 5 by 4. We will come to a conclusion of this, the video lecture, the topic, evaluation of double integrals for the bounded regions. This is the first problem in Cartesian form we discussed. The second one also, the Cartesian form we discussed. The third one, the circle, we discussed it, for which the first problem, the double integral xy by square root of 1 minus y square dx dy, first quadrant of the circle, that is only 1/4 of the circle, we concentrated, we evaluated. And the second picture, what we have drawn here, that is over the triangle, the 3 vertices are given, joining the points, the triangle is formed, and we used this equation of lines passing through 2 points, and we evaluated. The final one, the evaluation of this bounded regions, polar form we have taken. In the polar form, r equal to 2a cos theta, satisfying the circle is drawn, and we evaluated. The final result here, cos 8 power theta, the relevant formulas are introduced. We used those formulas. We made our integration very easy way. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.